Today I'm going to show you how to block ads and trackers, not just at home, but on every network you connect to, and all for the once-off cost of a Raspberry Pi Zero, which costs about the same as a takeaway meal. This is Pi-hole. Running on Raspberry Pi OS Bookworm and paired with Tailscale, it becomes a global ad blocker. Your phone, your laptop, your tablet, whether you're at home, at work, in a coffee shop, or using your mobile data, all your traffic is still filtered through your own Pi-hole. I've made a similar video previously, just on setting up Pi-hole on your home network, but that was a couple of years ago, so some steps have changed. So in this video, first we'll set up Pi-hole in the standard way, so it protects everything at home, and then I'll show you how to add Tailscale to turn it into something much more powerful. To be clear, Pi-hole doesn't run or inspect all of your web traffic, and that's why a Pi Zero can handle it. When you visit a website, you type in a name like google.com, but computers don't actually use names, they use IP addresses. The job of the DNS server is to translate the name into an IP address so that your computer can connect to it. Most websites don't come from just one place. The main content might come from one server, and the ads from a different server. So when your computer asks where the website is and where the ads and trackers are, Pi-hole responds by saying the website's here, but there's no address for the ad server. So your computer can load the website, but it can't load the ads and trackers, because it never gets their addresses. First, let's take a look at the hardware that you need. We'll start with a Raspberry Pi Zero, which is one of the cheapest Pis you can buy at only $10. It's important that you get the W version with Wi-Fi. If you use a standard Zero, then you'll need to add a USB network adapter or Wi-Fi adapter to it, which adds to the cost. You can also use another model Pi, but they're going to be overkill for this project, so save some money and go with a Zero. You also don't need the increased processing power of a Zero 2W. The original Zero W works perfectly for this project. In addition to the Pi, you need a heatsink. I'm just using a small passive aluminium heatsink. Then you need a microSD card for the operating system. Get a good quality card as it's going to be running 24/7. Lastly, you need a power supply to power it. The Zero is powered through a micro USB port, and you'll need one that can do 5 volts at up to 3 amps. Most good quality USB power supplies will be able to power it. And that's it for the hardware. All up, this costs around $15 to $20 depending on where you get the parts. The heatsink goes onto the Pi CPU, and we can then move on to flashing the operating system onto the microSD card. To do that, we're going to use Raspberry Pi Imager. Since we're not going to have a monitor hooked up to the Pi, it's quite important to get the setup right here, so don't skip any of these steps. First, we need to select our device as a Pi Zero W. Then for the operating system, we're going to be going to Other, and then choose the legacy Bookworm version of Pi OS Lite. This works more reliably than the newer Trixie version, at least for the time being. Then select your microSD card as the storage device. Under customization, give your Pi a name. I'm calling it Pi-hole so it's easily identifiable on my network. Select your localization settings to match your location. Set a username and password, which you should take note of. Then you need to enter your Wi-Fi network name and password. It's very important that you get this right. If your Pi can't connect to your Wi-Fi, then it's not going to show up when you power it up. And you'll need to then either hook it up to a monitor, mouse and keyboard, or reflash the card. It's also important that you enable SSH, or you won't be able to log into your Pi remotely. Now leave Pi Imager to finish writing and checking the card. Once you put the card into the Pi, plug it in and then wait 5 minutes to boot up. The first boot takes a bit longer, and the Pi Zero is not particularly fast, so you'll need to be patient with it. After 5 minutes, we need to start out by finding the Pi's IP address on our network. To do this, you can use a utility like Angry IP Scanner, or the easiest way is to log into your router and look for the Pi in your list of online devices or DHCP table. This is a bit different on each router, but to get started, the default login details are typically on the bottom or back of the router, and it usually involves going to the IP address and then using the provided login details, and finally looking for something called Online Devices, Clients or DHCP. Here you're looking for a device that recently joined the network, and it should be given the name that you set up when flashing the microSD card. We need this IP address to log into the Pi to continue setting up Pi-hole, and subsequently to maintain it, so write it down somewhere. While you're logged in, we also don't want this address to change if the Pi-hole router is rebooted, so we need to set it as a static IP. If you choose to change it, reboot the Pi so that the new IP address is assigned to it. Now that we have the Pi's IP address, we can log into it through SSH. This can be done in the terminal on another computer or through a utility like Putty. You'll need to log into the Pi using the credentials you set up when flashing the microSD card. Next we can install Pi-hole, which is a software that's actually going to be doing the ad blocking on the Pi. To do that, we just run this single line. It's okay to accept all the default prompts that come up. You'll then land up with an installation complete dialog that has some additional information on it. The most important bit of information you need from this page is the password that has been generated. You'll need this to log into the Pi-hole dashboard. If you go to the Pi's IP address in your browser on port 80 and /admin, you'll arrive at the Pi-hole web dashboard. Here you can enter the password that was given to you to log in. Now you should see your Pi-hole dashboard, which gives you stats like the number of queries blocked, the top sites and devices blocked, and how many domains you're blocking. You'll notice that most of these are zeros at the moment, and that's because we haven't told our router to use the Pi-hole as our DNS server. So let's do that next. This again depends a bit on the router you're using, but typically you need to log in again and then find a page or setting called DNS. This setting should have the options to set a primary and secondary DNS server. Set these both to your Pi's IP address. Some routers have weird rules guiding when they use the primary and secondary servers, so it's most reliable to just set both of them to the Pi's. And that's the basic setup complete, and your ad blocker should now be working. Let's visit a page that's likely to have ads on it. So we've got some blank blocks here, which is where the ads would have been served. So our Pi-hole's definitely working. You'll also see the counters at the top of the Pi-hole dashboard are now increasing. We've had 733 requests, 214 blocks, and that means over a quarter of all requests are being blocked, mostly because I'm intentionally going to a site that I know serves ads. If we temporarily turn the block list off, you can see we now have ads on the same page that we visited earlier. So now we've got an ad blocker working for all devices on our home network, but as soon as I take my phone or laptop away from home, I'll start seeing ads again. So that's where Tailscale comes in. So let's get that set up. First we need to install Tailscale. We do that with these two commands. Once complete, it'll give you an address to go to register the device on your Tailscale account. If you don't have an account, you'll need to create one. Once your Pi-hole's added to your Tailscale network, we need to tell the Pi-hole to listen on Tailscale. Open up your Pi-hole dashboard and go to Settings and then DNS. You might need to enable or disable expert mode to see the right-hand bar. Click Permit all origins and then click Save and Apply. Then head back over to Tailscale. Note your Pi-hole's Tailscale address. Then go to DNS. Scroll down to Name Servers and click Add a Name Server. Enter your Pi-hole's Tailscale address and leave the default selections. Click Save and then enable Override DNS Servers. And also make sure that Magic DNS below is enabled. And that's it as far as setup goes. Now all of your devices connected to your Tailscale network will also have their ads blocked wherever they are. Setting a device up on Tailscale depends on the device, but it's usually as simple as downloading an app from the device's app store, logging in and then following a couple of prompts. With it set up on my iPhone, if I'm on my home network then ads are blocked, and if I turn off Wi-Fi as if I'm away from home, you can see the ads are still blocked, now running through Tailscale. So now you have a global ad blocker running on a tiny Raspberry Pi Zero. It blocks ads when you're at home or away, it works with any device on your network, and you own the entire stack, so it's completely customizable and there's no monthly fees for it. If you found this video helpful, please leave a like or leave any follow-up questions or suggestions you have in the comment section below. Thanks for watching, and I'll see you in the next one.